For one on the exam.
It was number 8 of the question on the review.
I'm gonna go through. We'll go through all of them together. All right, first one. This is exam
4.
So it was n plus 1 over 3n minus 1. And it says write the first 4 elements of the sequence. So this is, if we call this an, a1 would just be simply plugging in 1, so that would be 1 is 2 over 3 times 1 is 3 minus 2, 1 is 2, so that would be 1. A2 would be 3 over 6 minus 1 is 5. A3 would be 4 over 3 times 3 is 9 minus 1 is 8. Which is that. A4 would be 5 over. See the pattern now, right? It's the next one on the bottom.
13. 13.
Well, hold on. 3 times 4 is 12.
Oh, 11. 11. Yeah.
Close. So it's increasing by 3, right?
Yes.
The top is starts at 2, 3. That's the first one. Second one just is find the limit of the sequence. Find the limit of an and determine convergence slash divergence. So an is equal to 2 plus 5n over 4 plus 9n, and we know that if it's a sequence, the only thing you can do is take the
limit.
other than
As n
squeeze.
approaches.
Yeah, that's right. Infinite limit. So
2n. I did 2n over 2n plus 5n over n. I put everything over n, and then
Okay.
divide by 4n, 4 over n plus 9n over n. That's the way I did it, and that's I came out with because then the ends cancel out.
Hmm.
And
so you end up with simply the coefficients of the highest power, which is 5.
right? And that's it converges to 5/9. The limit as of the sequence converges to 5/9.
So
Can we do it that way, or is there another way we're supposed to do it?
that's how you do it. It's fine. So an, usually I just say take the coefficients of the highest power and divide them. But this is how you show your work, which is fine.
I was thinking to write it down, like because of the coefficient the same, I put it 5 over 9. That would be right?
Yeah.
Okay, let's write it down.
And converges to 5/9. This one should be very clear, I mean, but find the limit of the sequence if it converges otherwise say diverges. So an that they give us is -1 to the n times 1 minus 6 over n. So right when you see this part, you should see that the limit will not exist because it's going to keep cycling from plus, negative, so it doesn't stop at any value.
It just diverges.
Is it 6 over n? 1 minus 6 over n?
So, yeah, 1 minus 6 over n is the sequence.
Okay.
So the limit of -1 to the n times 1 minus 6 over n
Oh, I put 2n. I put because I put 1 minus n to, and then I squared the n based off the formula that I found, and because you had 2n, 1 minus raised to the 2 to the n, so I put 2n.
Well, this is just a regular n.
Okay. Yeah, but it'll diverge or converge.
Yeah, it's the limit doesn't exist, so you would say it diverges because this limit will not stop at a specific number.
Okay,
Since the limit of a sub n does not exist, then the sequence diverges. It's going to be plus minus forever. Okay, next one. Determine whether non sequence converges or diverges. So a is 1 plus n times 4 to the n over 4 to the n. The limit of 1 plus n times 4 to the n. As n approaches infinity, what is that going to be? The limit.
Can you push the paper up a little bit?
it's gonna be n. Because 4 over 4 will be 1, and you'll have 4 to infinity will be 0, so you still equals 1. So it's just gonna be n.
So you agree that, so you're saying that these are going to cancel out, right?
Right.
But then you have n plus 1, so this limit is just going to keep going, right?
Yes.
So diverges. So since the limit is not finite, then an diverges.
Because if you split them like I split mine, I put 1/4, 1/4 to the n plus n times 4 raised to the n over 4 to the n.
Yeah, we could do that if you want. You would
Can
end
we-
up. You would
Yes.
end up with this guy, right?
Correct.
Let me write the limit. That's totally fine.
Okay, I was just wondering if it would be still the same.
As long as you make the same conclusion, right? This is still infinite. This
Then,
goes
yeah.
to 0,
Yes.
but the n keeps growing. And remember, I'm not canceling these. I'm just saying that these will grow at the same rate. So if you were to divide everything by this, you would end up with infinite anyway. Or you can separate and use algebra. There's nothing wrong with that. There's not just one way to do these questions.
We can cancel them. We can cancel them because the 4 is multiply n plus 1, so we can cancel the top and down, the
Yeah,
bottom and the up.
Yeah, you cannot. You're right.
I
But
cannot hear.
You can't cancel, no.
Okay.
They would have to be factored out.
Oh, yeah, it's multiply the n only. Okay, got you.
But because these are going to grow to infinity, then these parts are going to cancel each other when they're infinite, leaving
Okay.
you with this stuff. But algebraically, no, I can't just cancel this.
Oh, okay, got you.
So it's better to think of it this way, or to divide every term by 4 over n, 4 to the nth power. Those are the two proper ways to do it. The next one is a little tricky. Determine whether non-increasing sequence converges or diverges. One plus square root 11n over n.
And we take the limit of n approaches infinity.
So that's how we do all the sequences, right? You gotta take the limit.
11 n over n. And then I put I did equals and I separated. I put 1 plus 1 over n plus 11 n to the half, the limit. I'm sorry for that.
Yeah, you could do that.
And then I put 11. Well, I pulled the n out and I put 1/2. The n to the 1/2 on top. Can we do that?
Yeah, you use algebra to change it, right?
Yes.
Yeah, if your algebra is real, you're good. This is what you're saying, right?
Yeah, over n. Just like that, yeah.
So what is the limit? Is it clear now? Or not yet?
Yeah, it's 0.
Right, this is degree in the bottom is bigger. This one in the bottom is bigger, so 0. So the limit, or the sequence, an verges to 0. Right, so that's the end of the sequence. Now we're getting to the series. If you have any questions on the sequence problems? First pi sequence.
Okay.
Find the sum of the series. So as soon as I hear find the sum, there must be type that find the sum is easy,
like a geometric or something like that. But they're not asking about merging or diverging, they're just asking to find the sum.
right? So sum.
I
Let me remember the format. Check.
I used it's the geometric test. That's what I used, which was the summation of n equals 0 to infinity of r raised to the n.
There it is. Yeah, I think the n is only on the r, right?
Yeah, it's just the r raised to the n. There's it didn't in the book. It didn't show an a, so but it's supposed to have an a in front of it.
Yeah, the a could be 1, but in general, it's best to write it because it'll be part of the sum.
Oh, okay, so I gotta
If
make sure.
if r is less than or equal to.
Yeah, if r is less than 1, the geometric series covers to 1 over 1 minus r.
But they told us to find a sum, which means that the series must converge automatically. So we don't need to find out if it converges for this one. They already told me, right? If a sum exists, then the series converges, because otherwise sum would be infinite, right?
Yes.
So here's our question. I'm gonna put the 9 in front. 1 over 7. Rewrite it this way. Well, let me show this. Let's get it instead of circle. It's the book's job, right? Skip steps. 9 over 7 to the n. So rewrite this in this form, just so it's easier to see what's happening.
Yeah, I pulled the 9 out to the front of it.
You can pull it outside, that's true. But I'm leaving it there as my a.
Okay,
If you pull it out, you'll just multiply the sum times 9, which is the same thing, right?
I just want to make sure I was doing it correctly.
Yeah, so you're good. The only difference is I'm putting the 9 as part of the question. You would do the work and then put the 9. So doing it your way. So there's no real difference. So 7 minus 1, that'd be 9 over 6 sevenths, right?
Yes.
Which would be what? 9 times 7 is 21 over 2. Okay. So C, parts numbers, letter C is the option. Any questions on 6?
R is the second set of the series, right? I'm trying to remember.
R is going to be the factor that all the terms have in common. So you can find it by dividing two consecutive terms, usually.
Okay, thanks.
Think if it's not given. You can do that.
The next one's like that. Determine if the geometric series converges or diverges. If it converges, find its sum. So this time they're not telling me find the sum. So we don't know if it converges or not. If it doesn't, then there is no, the sums would be infinite. We don't have to find the sum. All right, so here is the summation or the terms. So what is AN?
So the summation is n equals 0. And I put in parentheses -9 and then raised to the n. Is that correct?
Yeah, because 0 gave me the first one, 1 gives me the second, 2, 3, so forth. So now that we have this series, right? Because they're not going to give you, sometimes you need to make this yourself. So they only gave you this. So this is the series. R is greater than, absolute value is greater than 1. Therefore, it diverges. Right? So the geometric test tells us.
So if we put, instead of putting r, we put -9 is greater than 1. That still means the same thing, right?
As long as you do it this way.
Okay.
It diverges by the geometric test.
Okay, so we have to write it like that. Whatever.
Yeah, you gotta tell me why. I don't want to see converges, diverges. That's all. But I don't want to see that.
Okay.
That's 0 points. That's just a 50-50 shot, right? That doesn't really do anything. Next one is similar.
Guess so. Oh no, you requested number 8, so let's go ahead and do it. Determine if the geometric series converges or diverges. If it converges, find the sum. Right. So they give us a list of fractions being summed up. Forever. So similar to before, our series would be this, the pattern here. It's gonna be,
It wouldn't be n to the 1.
yes, for this one, you would have to, right?
Top right.
Otherwise, I'd have to change this part.
Is it 1 over? Right.
only issue is it okay to start out? Because the formula says it needs to be 0. So we may need to adjust.
That's what I was trying to figure out why, how to,
Yours didn't come up?
it didn't come out with the one, I was trying to figure out how to, that's why, this is the one I got stuck on.
Is the R will be 1/5? Like we have everything we need, right? Or no?
So we can rewrite it like that and just put so would the 1/5 be raised to a 0? Minus,
Hold on a sec. So I want to get a 1/5 for the first one. So because this would not give me, it would give me an extra term, right?
yes.
So what I need to do is subtract that extra term to force it.
It would be 1/5 to the n minus 1 to the 5th, 1/5, 1/5 to force it, or just 1?
Because I only want it to happen once, right?
Oh, okay.
So I want this to be part of the series. One second.
Double check something before.
So the sum. So sum would be a over 1 minus r, which is 1/5 over 1 minus 1/5, which would be 1/4. So that's how they get the 4. So since the r is less than 1, since absolute value r less than 1, then the series converges and has a sum of 1/4. R is A is 1. Yeah, that's all you have to do. So that's how to get the 1/4. You have to. Sometimes the hard part is figuring out what is the AN. You have to think about it.
You guys have any questions on this one?
I got you now.
Okay.
Number 9. This question is telling me which test to use. Use the nth term test, which is the divergent test, right? Remember, it has 2 names for divergence, to show that the series is divergent. Or state that the test is inconclusive. So in this question, they just want you to try out the diversion test and see if it works. If it doesn't work, you don't have to do anything else because that was the instructions. Here is the series. N over n plus 6. Just take the limit, right? And divergence test means take the limit of the sequence as n approaches infinity. And if that is equal to anything other than 0, then the series diverges. So since
I did n over n divided by n over n plus 6 over n.
yeah, that's how you show your work. I think that's a good thing to do.
Is this limit equal 1?
And then
Yeah.
equals 1.
Why? Can you explain very quick? Is it because infinity over infinity plus 6 means infinity over infinity equal 1?
Yeah, let's show the steps he was talking about. Sorry about that. So you divide every single term by the highest power, leaving you 1 over 1 plus 6 over n. When you take the limit, this goes to 0.
Got it. Got it. Got it.
Since the limit
Thank
of
you.
an is not equal to 0, then
Diverges.
series diverges. I think I'll leave space for these next two. You have any questions on either?
Since 1 is not equal to 0, the series is divergent. All right.
Second. You all right? Yeah. Questions? Use the integral test to determine whether the series diverges. So what we do, right, is we change this into, well, we take an integral and then proper. We say as the limit as n approaches infinity, call it to keep it consistent. The integral from 1 to b, 1 over 2n minus 1. The, oh, and the note we change it to x. We change that. So, okay. Now integrate this. What is the integral of 2x? Minus 1. What technique should we use?
U sub the 2x minus 1.
Let's do U sub.
So let u equal 2x minus 1. Du would be 2 dx. So du over 2 is going to be dx. So the limit b approaches infinity from 1 to b, 1 over u, and d over 2, I'm going to put the half. Skip a step there. So this would become 1/2 ln u from 1 to b, but we need to change it back to x if we're going to stick with those bounds. 1/2 ln 2x minus 1 from 1 to b. This will be infinite, won't it? Do you see why, or should I show why? Is it clear?
So we didn't need to take the first derivative? Do a first derivative test?
No.
Oh, you mean to check if it's decreasing and all that stuff?
Yeah.
Well, they told us to use it, so it's implied that it's okay.
Okay, so
But if they just say, does it converge or diverge, and they don't tell you how to, they don't tell you anything, then you should probably check the test to see if you are able to use it in your protest.
Since the integral is infinite, this series diverges.
Let's skip the next one because there's a lot of questions. Yeah, the next one is the same thing. It's just a U sub.
U is integral. So I'm going to skip this guy. See how the integral would be easy, right? N equals 1 to infinity. 3n over n squared plus 4. This would be a simple U sub. Diverges. So you do that one. Number 12.
Oh, it's different.
It says use ratio test to determine if the series converges, diverges. So remember I told you whenever you see the factorial, it's gonna be ratio, but they told us anyway.
So it says the limit approaches infinity to the absolute value of a to the n plus 1 over a to the n, which equals L.
Yeah, it's going to be the an plus 1 over an.
Which is the limit of n plus 1 factorial to e to minus 7 n plus 1 over e plus n over e minus 7n.
Maybe you're right. So in order for it to converge this ratio, it has to be less than 1, right? It's greater than 1, diverges, or infinite. It's equal to 1, then we know nothing. So let's go ahead and write down an is this basic thing, right? Like you said. An plus 1 is going to be n plus 1 factorial e to the negative 7, plug in n plus 1, which is going to be n plus 1 factorial e to the negative 7 n 7. Now do the limit. N approaches infinity and creates this ratio. Absolute value. So this guy is on top. That should be a negative 7. Negative 7 and 7.
Over e to negative 7.
Yeah. So let's go ahead and expand it so we can see what cancels, right? This would be n factorial times n plus 1. This would be e to the negative 7n times e to the 7. Factorial, not going to change the bottom. So this cancels, and this cancels. So now I have limit infinity of plus 1 e to the negative 7 over, there's nothing left, right? Looks like infinite to me, doesn't it?
Isn't it over e to the 7?
Yeah, it doesn't matter because it's just a number.
Okay.
Yeah, you can pull this guy down there, right? But n will keep growing forever.
So since the limit an plus 1 over an is equal to infinity, and this series diverges by the ratio test.
Is there any questions on 12?
No, not at the moment right now.
13 is similar, but we'll go ahead and do it. So I was going to say use ratio test, the same instructions. The series they give us n equals 1 to infinity of 8 to the n over factor. So label an sequence. Label the an plus 1.
Raise it up, please.
So now take the limit of the absolute value of the ratio an plus 1 over an. Let's see what happens. So that would be the limit of an plus 1 n plus 1 factorial times n factorial times 8 to the n. Okay, and then we'll expand it like before. It'll be 8n times 8 times n factorial, n plus 1 times n factorial.
Can you push it up a little bit? Thank you.
So we'll cancel our like terms, which will leave us with the limit as n approaches infinity, 8 n plus 1. So what is this limit?
0.
0. And so since the limit an plus 1 an is equal to 0, which is less than 1, right? That's a requirement.
Yes.
Then the series converges.
I have a quick question. When we reach to the limit n equal infinity, 8 over n plus 1 equals 0, I have to show why it's equal 0, or I just can write it this way?
Say it one more time. Sorry.
The last step, limit n equal to infinity, 8 over n plus 1 equals 0. I have to prove why 8 over n plus 1 equals 0, or it's obvious that no steps needed?
I mean, you should show why, or you can give me like a small explanation and just say,
Okay, yeah, like as an n plus 1 keep growing up until, okay.
yeah, this since the bottom is going to infinity, this will go to 0. But to show it, you would divide each part by n.
Yes, I got it.
So either explain the theory or show it. I just didn't have space. But this one, there's nothing to show, right?
Yeah.
It's gonna be, now it's clear. Should be clear. The next one is similar, it's just ratio again. So I already did 2 ratios. Let's move on to the root. I like the root because it's kind of easy. Use the root test to determine if the series converges or diverges. All right, so when you see a nth power, you're gonna want to use a root test because that'd be the easiest route. You don't have to, I recommend it.
That's number 15.
I think it's 15. Yeah, 15. So use root test. It has the same rules as the ratio. So you take the limit of the nth root of an, which would be the nth root of ln n over 9n plus 1 to the n. So that would cancel, right? Leaving you with so at this point, what is the greatest power? Does ln grow faster or does 9n grow faster?
I'm right. It was ln that grows faster.
Let's look at it. We can graph it. Let's see. Y equal x, y equal x, right? It's like ln is pretty slow, right? So I would say that the degree of the bottom is more powerful. So what you can do to show your work, you can say, you know what? I want to divide every single thing by the highest power. Honestly, I think I'd rather, it's going to be the same thing. You should just use a logical argument. Since n is greater than ln n, this limit go to 0 because the denominator grows faster. Since limit of the nth root of AN equal to 0, which is less than 1, then the series converges. Sorry.
Okay, the next one is also a root test, which will be show you. This one, you just take the limit, and these will both go to 0, so converges. See what's left here. Yeah, I think we'll leave the last few for next time.
Yeah, I haven't got a chance to work those ones out. I was having problems with the other ones earlier, so I was working on those, getting more familiar with those.
You got you. Because after this one, they don't tell you what to use anymore. Notice that? They say, figure it out, right? Over here, it's one radius of convergence, and they don't tell you how to approach it. Same thing. And this is when the Taylor and Maclaurin. So when we take all those derivatives, find the pattern. That's where this starts. Last three. Yeah, you guys have any questions on the first 15 or so?
So all you want us to do is to come up to where we show where it equals, and then we just explain why it equals 0 and why it diverges. Use this, or we could just show our work.
Yeah, show your work or explain why the limit is 0. If you don't show, and if you just write 0, then you need to explain. If you show your work, then you can go straight to explaining why it converged or diverged.
Okay. And that's with all the ones that
Yeah, for all of them, because you're probably going to be doing the limit of almost all the questions. So.
Okay. So I gotta go back and.
Yeah, we'll do more on Wednesday. So good. I'm getting hungry. You guys have any other questions?
No, that's it.
I had some technical difficulties with my computer. So I'm on my phone right now, but did I miss anything in the first 30 minutes or so, or at least hour?
We went through the whole. Well, we went through about half, a little over half. I guess more like 80% of the review.
Oh, okay.
So, but I'll post it either way. So.
Okay. Yeah, I just want to make